Hello everyone. So in this video, we are trying to find the impact of female literacy rate, per capita income and total fertility rate on child mortality. So defining the first variable is child mortality. It is a numeric variable and decimals, there's no decimal value in it. Okay. So we have defined this as child mortality. Our second variable is female literacy rate. Here also there are no decimals value. Our third variable is per capita national income, gross national income, which is per capita gross national income. And looking at this value, this also doesn't have any decimals. A fourth variable is total fertility rate, which shows the expected number of child a woman bore in her lifetime. So the decimals are present in this case. So suppose our first question is to find mean and standard deviation of per capita GNP. So we can go to analyze descriptive statistics and then descriptives. Here we need to find for per capita gross national income. We can find the range as well, standard error, variance. Okay. Okay, so we'll get to this. So the per capita, average per capita national income is 1695.16. We have got the standard deviation. You can see the range and variance as well. Okay, now moving to, suppose we are supposed to, in this case, child mortality is the dependent variable, which is being influenced by female literacy rate, per capita national income, and this variable 4 was total fertility rate. Now, if you want to analyze, suppose, so selecting it as a dependent variable, whereas female literacy rate, per capita income, and total fertility rate are the independent variables. We'll get this result, which states that the sign of the total fertility rate is minus 0.61%, which means as the female literacy rate increases, the child mortality would decrease by 0.61%. And this is t-value is very high, and it is significant since p-value is also very small. Similarly, for per capita national income, this states that if per capita national income increases, child mortality would fall, which makes sense as well. And it is significant at 10% level. And the total fertility rate is 0.26, which means if a woman bore more number of children, it is expected that the child mortality would be high. So if total fertility rate increased by 1%, child mortality would increase by 0.26%, which also makes sense because as the number of children a woman bore increases, the expenditure on them gets distributed, so they are not able to raise the children that much efficiently. Okay, now suppose we are supposed to find the, okay, now we can check whether the residuals are normally distributed or not. Firstly, we can use the regression, same thing, and we can go to save, and we can select on residuals so that we will have residuals as well. So this is the residuals. These are the residuals of the model. Okay. We have got the residuals. Okay, and this model, what we have is R square is 0.72, adjusted R square, which is always less than R square, is 0.71. T ratio tells you about the significance of an individual variable, whereas the F ratio tells about the significance of all the independent variables taken together. Okay. Now we need to check whether it is normally distributed or not. So we'll go to graphs, histogram, we'll draw the residuals and we'll select this display normal curve so that we'll have an idea whether they are normally distributed or not. Okay. So we can look at this. So more or less, we can see they are normally distributed only. Okay. Now suppose we want to transform the variable in the log form, log len, which is we want to regress log CM on log FLR, log per capita national income, and log total fertility rate. So we'll transform the model. We'll go to transform, compute. Here we will have log CM. And on this right hand side, we can see what the formula of log we are supposed to use. This log 10 and the number. LG 10 bracket, and we're not supposed to type CM. We are supposed to click on it and then put it inside. Then bracket close. We'll get the log CM value. Okay. Similarly, we can do this for other variables. Compute. Now we need log FLR, and this would be putting this variable into this. Then we can do this for per capita national income, gross national income. And lastly, we can do this for total fertility rate. We are not supposed to type it. It's supposed to move this variable inside the bracket. Okay, so we have this. Now, if you want to regress log CM on log total fertility and all the other variables, we can analyze, go to regression, linear, and then okay, we can move them back, all the already variables which were already included in the model. Okay, now log CM is our dependent variable, log FLR independent. Okay, we can accordingly do this. Okay, so we'll get the results here. You can see his R square is coming out to 0.81. F value is highly statistically significant. So the interpretation of this would be if female literacy rate increases by 1%, so if female looking at this coefficient beta, so if female literacy rate increases by 1%, the child mortality rate would fall by 0.21%. Okay, because these are both in the log format. Whereas in the previous scenario, they were not in the log format. So a 1 unit change in this would lead to 0.61 unit change. But here, these expressions would be in percentage term. So log PC per capita national income would suggest if the per capita national income increases by 1%, the child mortality would fall by minus 0.32%. Similarly, for total fertility rate, if total fertility rate increases by 1%, child mortality would increase by 0.56%. Okay, I hope this was clear.